This is Dr. D. Kumutha, Associate Professor, Department of Biomedical Engineering, Karpaga Vinayaga College of Engineering and Technology. So the research title is a compact infused 5G multiple input, multiple output antenna for wireless communication. So here the abstract is used to propose the MIMO antenna, which is operating from 20 GHz to 30 GHz, being implemented for 5G application. Hence, this antenna is designed for FR substrate with concentric circular slot and corner truncation in the patch. So hence it is used to implement the mean-bear lines, which cause the resonance at 20.9 GHz, 25.5 GHz, 26.9 GHz and at 28 GHz with good return loss and gain. So hence the SIA4 single input single output is converted into MIMO antenna with a substrate size of 30 into 30 into 1.6 millimeters cube. Moreover, the correlation coefficients and gain can be analyzed to get a good manner to determine the diversity performance. So and also the 5G wireless communication is focused as a good candidate for future 5G wireless communication to provide a virtual reality devices. So, and what is the objective of this paper is to develop the antenna resonating at 28 GHz for 5G mobile communication using CMI. And now, what is the introduction of MIMO antenna for 5G wireless communication is communicating between two or more devices using a wireless signal. Multiple antenna also used in both the transmitter and receiver, and also provides high data rate communications with bandwidth efficiency. And MIMO is a large-scale wireless communication to meet higher throughput, improved quality of services of next generation, to reduce the operational power consumption and use of low complexity schemes. So, and hence the 5G network is used in the next generation of mobile communications, which is used to provide a high bandwidth, and also this single antenna systems with a high isolation in the transmitter and receiver of the user equipment is more demanding. And in MIMO antenna systems, the important features are high data rate, increased channel capacity, higher isolation between antenna elements, low latency, high quality of service within restricted amount of power. The frequency spectrum of 5G is classified as sub 6 GHz and millimeter wave. In this 5G wireless communications will support spectrum bands of sub 6 GHz and millimeter wave, that is a spectrum above 24 GHz. So why 28 GHz? Why the CMI? Compact size mean the infused MIMO antennas used 28 GHz is lies between 20 GHz to 30 GHz in the 5G applications. So here the 28 GHz and 38 GHz are robust frequency bands, because at this frequency we are getting more advantages, that is the attenuation of the Harris flow, higher data rates and lower latency can be achieved, and carrying out high speed communications intended for future 5G communication network. And this is the design flow. First we have to start and we have to select the materials, what type of materials we are going to use for designing the antenna, and after that a design of structure and the equations can be formed. Then performance evaluation can be calculated by using the CMI, then for software simulations of planar antenna, and finally the expected results can be obtained. So now we are going to see the software used is the high frequency structure simulator. So it is high performance full wave electromagnetic field simulator for 3D volumetric passive device, and also this is used to integrate simulation, visualization with solid modeling and automation in an easy to learn environment. And this AND-soft HFS employs the finite element method, adaptive machine and brilliant graphics to unparalleled performance and insight to all 3D EM problems. And AND-soft HFSS can be used to calculate the parameters such as S parameter, resonant frequency and field. And also the main design of using HFSS is to create a parametric model generation, analysis setup, results, solve loop. And here is the proposed system. What are the materials and the components are used to design the thickness, patch, corners, ground of the antenna, length of the feed line, width of the feed, and etc. to use in the CMI. So, and here FR4 is substrate having 4.4 permittivity, and the area consumed by the patch design is 14.55 into 15.68 into 1.6 mm3. And what is the thickness of the copper is 0.035 mm, and patch is 0.5 mm, and also we can use 1 millimeter and 1.25 millimeter. And the corner of the patch is 0.8 mm into 0.5 mm, and ground of the antenna is 15.68 mm into 4 mm. The length of the feed line is 9.05 mm. And finally, the width can be calculated for 0.5 mm wide. This inclusion caused resonance at 20.9 GHz, 25.9 GHz, 26.9 GHz, and 28.2 GHz with good return loss. And now we are going to see the structure of the designed antenna. Compact size mean the infused MIMO antenna. So the front view can be given here, how much the width and the length can be calculated, and here is the rear view, how much meters are represented in the compact size mean for infused antenna. And this is the width of each and every substrate, patch, and the feed width, everything as shown in this figure. And here are the keyword, full form, and the dimension for each and every one. LS is nothing but it is a length of the substrate, and we can use 14.55, and WS is the width of the substrate, 15.68. LP is the length of the patch, 6.08, and WT is the width of the patch, 3.94. LF is the length of feed, 9.05, and FW is the feed width, 0.82, and finally FW2 is the feed width to 0.5. And this is the simulation results for each and everything. The result return loss can be calculated with the frequency versus voltage standing wave ratio, frequency in the x-axis, and WS, WR in the y-axis, and same way VSWR can be performed in the range of frequency versus return loss, and it is developed into 4-port MIMO antenna system, and the antenna was operating between 20 GHz to 30 GHz, exhibiting an impedance bandwidth of about 10 GHz. A single element exhibited a maximum gain of about 12 dBi with the entire operating frequency gain above 5 dBi. VSWR was also less than 2 for the entire operating frequency with efficiency of about 70%, and this is a comparative analysis for the existing and the proposed work, and these are the substrate how much we can use, and this is the band covered, and dimensions, the number of ports can be used, and what is the gain and the efficiency and MIMO parameters can be used. So in the proposed work we used FR4 bandwidth covered between 20 GHz to 30 GHz, and dimension is 30 into 30 into 1.4, and the number of ports is 4, and the gain is to about 12 dBi, and the efficiency is about 75%, and ECC is 0.02, and DG is 9.99. And these are the implementation of MIMO. There is a rear view of MIMO design and front view of MIMO designs with 30 mm to 30 mm of CMI. And here return loss, frequency versus return loss, and this is the isolations output which is simulated in HFSS, and here is WSR, and then gain can be calculated in the x-axis and y-axis, and here is ECC, DG, diversity gain, efficiency, envelope code, and the frequency presents in the x-axis, and y-axis ECC can be used, and thus the MIMO antenna is designed to operate at 20.9 GHz, 25.5 GHz, and 26.9 GHz, and at 28 GHz, the good return loss, gain, and efficiency. The antenna becomes a very good candidate for millimeter wave frequency, satisfies the MIMO parameters such as envelope correlation coefficient. There is a ECC which can be given in the previous results, simulated results, and the diversity gain. See here, mainly we can use for ECC, that is the envelope correlation coefficient. In the x-axis it ranges from 18 to 34, and in y-axis we have 0 to 0.0008, and in the same way diversity gain also ranges from 18 to 34, and the range can be given here. There is 9 point and many decimals to 10. And then efficiency ranges from 18 to 32 ohm frequency, and the efficiency is 0.5 to 1. Hence, we obtained the 28 gigahertz with a good return loss for using the CMI and MIMO antenna system. So by using the 5G wireless communication. And these are the reference we used for this work to obtain the CMI MIMO antenna in the 5G wireless communications. And here we have already published 2-3 papers by having super compact FR4 compatible 28 GHz antenna for 5G handheld devices, and also survey on planar antenna for 5G applications, and we have mutual coupling reduction technique between MIMO antenna for UWB. Thank you.